In today's lesson, I want to go through maybe a quick run through of solving linear equations, starting with a basic one here where if you want to solve this equation for x, you're trying to find the number that when put in place of x makes the left side equal the right side. You could always try to guess your answer, but a better approach would be, I think we should try to simplify both sides and then add, subtract, multiply, or divide both sides by something to get x by itself. So as I look through this expression, on the left side, I say I can distribute this -8. And here I have a -1 that gets distributed to both terms. So I'll start there, just simplifying both sides. All right, so -8x is our first term. And then we get, well, it's going to be +24. I'll copy down the plus 2x. And this is equal to 1. And when you subtract something in parentheses, it just changes the sign of everything inside the parentheses. So it's going to be a -3, but a +2x. So first, kind of like get rid of the parentheses by distributing. Now I'll look through both sides and try to combine some like terms. Like here I have a -8x and a +2x. And on the right side, I have a 1 and a -3, which I can combine, but nothing else beyond this. So let's see. I have -8x plus 2x, which gives me -6x. And then I have plus 24. On the other side of my equation, I have a 1 minus a 3, which is a -2, and then a plus 2x. And once we get to this point, we're kind of like stuck in terms of simplifying. But if I were to add or subtract the same thing to both sides, my new equation will still be valid. The left side will still be equal to the right side. So you can do this in a couple of steps. So maybe I'll start there. Let's see. I think what I'm going to do is start with the x's. I know if I add the left side by 6x, cancels the 6x's, but I have to do the same thing to both sides. So I'll just line up the like variables and go from there. So the -6x and +6x cancel. I'm left with 24, and this is equal to -2, but then we have plus 8x. Okay. Okay, now our last step here really is going to be, okay, I have a -2 on the right, but if I add both sides by 2, I'm getting closer to having x by itself. Now what I have is 26 is equal to the -2 and +2 cancel, and I'm left with 8x. Great. So there actually is one more step beyond this, but again, the idea being I want to do the same thing to both sides. Before it was just adding and subtracting, but here if I take both sides and divide them by 8, my resulting expression will also be equivalent. So I have on the right, the 8's canceled to give me an x. And then 26 divided by 8 will not go in evenly, but we can simplify that. And there's a factor of 2 that goes into both of these numbers. So let's see. 8 has a 4 left over. 26 is going to have 13. So you could write your answer as 13/4 as an exact value. It'd be okay to use a decimal as well. There's nothing wrong with that. This would be the same thing as saying 3.25. Both are completely okay. You could use a mixed number too, but in this first example, it really was just a matter of how do you solve an equation? The idea is you want to do the same thing to both sides of your equation. And this is our final answer. For the last two examples, I just wanted to look at what happens if you have fractions. The last one's going to be what happens if you have decimals. For this example here, if you don't like working with fractions, there's a very simple way to cancel it from your equation. And to do this, you can multiply both sides by the least common denominator. So here our denominators are 3, 2, and a 6. And since both 3 and 2 can multiply to 6, I know that this would be my least common denominator between those three fractions. So this is going to work out really well, that if I take both sides and multiply by 6, it's going to cancel every single denominator, and I'll still have an equal sign between the two sides. So let me write that next. It'll look a little messy, but I'll have 6, and I'm going to write the entire left side over again. And whatever I do to the left, I have to make sure I do to the right. I think the right side is going to be quite a bit easier, but that's 6, just to be careful here. I'll write times 5 over 6. I've clearly done the same thing to both sides. The entire left side and right side have both been multiplied by 6. So maybe as my next step, the right side's very simple. You could take care of that right now if you'd like to. I know that 6 is 6 over 1. 6 goes into itself one time. The whole right side is actually just going to be 5. What is messier is what we get on the left. This 6 gets multiplied to your first and second terms inside the parentheses. So I'm going to be a little bit more careful here, where I'm going to write this as 6 over 1 times 2x plus 1 over 3. And then I'll repeat that. I'll have plus 6 over 1 times x minus 1 over 2. And I know this is just going to be equal to, after the right side is simplified, we just have 5. So here, like, you could just multiply your fractions together, distributing 6 into the 2x plus 1 and also the x minus 1. But instead, I think what I'd like to do is cancel 3 and leave a 2 left over in the numerator. This is why the least common denominator of 6 works out really well. The denominators end up just being 1, and it evenly goes into the 6 that's in the numerator. So like here, we have 2 goes into itself once, but it has 3 left over in the top. So I'm just going to write this next step carefully. This first part really means 2, and that's multiplied to the whole thing, 2x plus 1. There's no denominators to write down. Same thing for the next piece. It's 3, and then you have x minus 1 left over. After here, it's just 5. So once you see this a few times, it is not difficult to jump from the very first equation to the step that we just wrote down. But it might, take a little bit of getting used to. I'll scroll down a little bit here. So now we're kind of back to an equation that was much like our first one. I want to get rid of my parentheses, combine like terms, and get x all by itself. So what I'll do is distribute the 2 into the parentheses, the 3 into the parentheses, and go from there. We have 4x plus 2. Then we have plus 3x minus 3 is 5. And again, on the left side, I have some like terms. 2 and the minus 3 can be combined. So we get a total of 4x and 3x is 7x. See, 2 minus 3 is negative 1 is equal to 5. I can now, all right, I can add 1 to both sides. This gives me 7x is equal to 6. And now if I just divide both sides by 7, I have my answer. I'll put that over here, but x is by itself, and that's equal to 6 over 7. Okay, with our final example, it's like the other thing that could show up in your equation. So now we have decimals instead of fractions. And if you could actually just work with decimals. There's nothing wrong with just distributing the 0.2 or the 0.8, combining like terms, but a nice trick is to multiply both sides by something that'll cancel all those decimal numbers for you. So like 0.4, if you multiply it by 10, becomes 4. 0.2 becomes 2. 0.8 becomes 8. So the trick here is to note that if I multiply these 3 things by 10, they just become integers. So why don't we try this? let's actually multiply both sides by 10. I think it'll look a little messy at first, but once you see the trick to it, it's very easy to just jump from our very first step to our final equation. So I'm going to write it out as this. I have 10, and I'm multiplying it to the entire left side, which is 0.4x plus 0.2 times 4x plus 1. And then on the right side, I have 10, and that's being multiplied. Well, really, there's just one giant term here, so that's 0.8 and 2x plus 1. So there's really nothing to even distribute. I think the left side is going to take quite a bit more work if I look at it. 10 is being multiplied to this first piece, and then to this whole second piece here. I mean, really, I'm going to multiply it to just the values in front because they'll combine nicely with the 10. However, on the right side, this 10, there's only one term in the larger bracket, so I'm just going to multiply it to the 0.8. And let's see what this looks like. So 10 multiplied to the 0.4x, well, 10 and 0.4 is just 4, and it leaves me with x left over. 10 times the 0.2 is going to give me 2, with my 4x plus 1 remaining. So I've now distributed the 10. And on the right side, it's really nothing to distribute. It's just 10 times 0.8, and that is just simply 8. So the nice thing with examples 2 and now example 3, it's that if you have fractions or decimals, there's something you can do to take it back to something that resembles the first example that we looked at, where you're just distributing and combining like terms. So let's complete this question. Scanning across, I'll distribute the 2, I'll distribute the 8, combine any like terms, and go from there. Okay, so let's see. This is 4x. Then we have plus 8x plus 2. And that's equal to 16x plus 8. On the left, okay, we have a 4x and an 8x, which is a 12x plus 2. That's equal to 16x plus 8. So simplify both sides as far as we can go. I'm going to try this in one step where, okay, I know I want all the x's on one side, all the numbers on the other. I'll probably have to divide after that. So I'm going to try this in one step where I'm going to subtract 12x from both sides. I've done the same thing to both sides of my equation, so I know my result is still going to be equal. But why not at the same time, I'm going to subtract 8 from both sides. You can do 2, 3 things at once as long as you're doing the same thing to both sides when we have this addition or subtraction, but I'm subtracting 12 and subtracting 8. I'm definitely doing the same thing to both sides of my equation. So let's see what that does for us. The 12x minus 12x cancels. The 2 minus 8 gives me a negative 6. I have 16x minus 12x, which is 4x, and my 8 minus 8 cancel. This is it. You can either think of a number that works, or I think what I'll do is just divide both sides by 4. And I'm there. That's negative 6 over 4 is equal to x. You could simplify this if you want to. I know there's a factor of 2 in both of those terms, so that's negative 3 over positive 2. Or if you wanted to do negative 1.5 as a decimal, that's completely okay. You can use mixed number as well. That's completely acceptable, but all of these are fine. So x, I'll say, is equal to negative 3 halves, and that's the answer to this equation.